Good morning, everyone. My name is Lydia Rycroft, and following on from Simon's introduction there, I would like to provide you with an overview now of the Work Package 5 work, which is on the development of industrial hubs and clusters. Next slide, please. A CCUS hub and cluster network brings together multiple carbon dioxide emitters, referred to as an industrial cluster, to make use of shared transportation and storage infrastructure. The term CCS hub refers to the central collection or distribution points for CO2. Hub and cluster networks offer several distinct advantages for network participants compared with point-to-point projects. The hub and cluster approach reduces costs and it incorporates economy of scale and shared infrastructure. It also reduces risks for many potential projects as the system is more flexible. Areas where there is both a high concentration of CO2 emitting industries and a nearby capacity to store emissions are considered prime sites for hub and cluster developments. Next slide, please. The Align work in Work Package 5 has advanced the development of CCUS in 6 separate industrial clusters, which are spread across 5 countries. Each cluster has had a different research focus within Align, whether it's looking at the impact of incorporating temporary storage for shipping, optimizing business models to reduce costs, or identifying potential source and sink matches. I will therefore briefly go over the individual clusters now within this work package Align, just so you are aware of what information has been developed at which sites and what information is now available to download from the Align website. Next slide, please. Two UK case studies have been developed further in Align, one in Teesside in the northeast of England and one in Grangemouth, Scotland. This work has focused on cost reduction by research to inform the next steps for large-scale and long-term industrial CCS, building on and far beyond the initially planned UK projects. This research is very much in step with the UK government ambitions, and during the Align project, the UK government launched their Industrial Strategy Decarbonisation Challenge, to support cost-effective decarbonisation of industry for net zero. This has led to the clusters updating plans during the Align project, and the latest developments have been taken into account. The Teesside Industrial Cluster currently plans to decarbonise carbon-intensive business starting by 2030, and Grangemouth and the Central North Scotland Industry Cluster is being developed alongside the Acorn project for storage to begin in the mid-2020s. The Align UK case studies have accelerated next steps to achieve capture and storage at tens of millions of tonnes per year. It has done this by simulating containment and capacity of multi-site storage options, assessing risk and liabilities and recommending appropriate business models, and modelling cost-effective and optimal networks for the transport and storage options and for the recommended CCS business models. Overall, the work from these case studies will inform UK decarbonisation beyond the industry's remit, and provides a wider perspective for policy and decision makers. Next slide, please. The third cluster researched in Align is based in the port of Rotterdam. In this task, the technical concept of large-scale hydrogen production produced from natural gas has been developed. A pre-feasibility study has been conducted, which has assessed the technical feasibility of developing a centralised hydrogen production facility alongside CCUS. This task has been based on the H-Vision concept currently being developed by industry partners in the port already. The Align work has identified the scope of facilities that would be required and also the necessary modifications that would be required. For example, the conversion of coal-fired power plants in Rotterdam to hydrogen-fired power generation, and also the further utilisation of hydrogen in existing and new processes for the port region. Work has also been conducted to assess the financial feasibility of the concept through the development of a bespoke spreadsheet-based techno-economic model. Next slide, please. An assessment of possible cluster developments in North Rhine-Westphalia region in Germany has also been undertaken within this work package. This task has assessed the potential for the utilisation of CO2 and hydrogen, specifically for use in synthetic fuel production. This task therefore ties in with the CCUS demonstrator investigated in Work Package 4, where synthetic fuel production is being researched, which Peter Moser will be providing more detail on shortly. For this task, a database has been produced of CO2 sources alongside a forecast of synthetic fuel demand until 2050. Modelling of potential CCU pathways have allowed for an assessment of optimally plan the fuel plant location, how to conduct the CO2 source selection, and the necessary network developments required. This task has therefore provided a description of different pathways concerning CO2 reduction potential, the associated costs, and the potential adaptation of infrastructure to allow for sector coupling. Next slide, please. The next cluster is based in Norway. The Grenland cluster is the name of an area in southeastern Norway, centered around the towns of Porsgrunn and Skien. A number of process industries are located in this region, including the Norcem cement plant, the Yara fertilizer plant, and the waste incineration plant in Oslo, operated by EGE. Given the relatively close proximity of these three sources to be covered in the Grenland cluster, the development of a multi-user CO2 infrastructure is likely to be economically and operationally efficient. A concept for a joint interim storage site for CO2 at Herøya Industrial Park near Porsgrunn was also conceived during the Norwegian CCS study. This site, or CO2 hub, would be designed to receive, handle, and load CO2 from three different sources onto maritime vessels ready for transportation. This transport aspect has been covered in Work Package 2 of the line. Within Work Package 5, a pre-feasibility study of a joint intermediate CO2 storage site in the Grenland region has been evaluated, including the technology, engineering, operational, spatial, and financial requirements of the facility. This research has identified how different approaches in the full chain can affect the design requirements of the storage site and has optimized the operational efficiency of the total source sink system. The industrial partners of Align, Norcem and Yara, have been actively engaged in the work, delivering data concerning emissions, CO2 stream composition, and site outline to support this Align work. Next slide, please. The final cluster in Align is based in Romania. The Oltenia industrial cluster is located in the southwestern part of Romania, west of the Olt River. The industrial cluster located in this region comprises mainly power generation installations, an aluminium production facility, and soda production facility. Energy production in this region is based on local lignite and accounts for almost a quarter of total Romanian gross electricity production. Most of the CO2 emissions in the Oltenia region are produced by energy generation facilities. The CO2 industrial emissions in this region represent approximately 40% of the total Romanian industrial CO2 emissions. Work in Align has developed a blueprint for the industrial cluster, identifying the most feasible transportation routes for future captured CO2, and has investigated the storage solutions available, including the possibility to use CO2 for enhanced hydrocarbon recovery in the region. Following the source and sink identification, potential CCUS pathways for the Oltenia region have been described, highlighting the different pathways concerning CO2 emission reduction potential. This includes necessary infrastructure, transport routes, and potential storage options. Next slide, please. The final task within a Work Package 5 is focused on identifying the cluster synergies, moving away from an individual cluster or national CCUS focus and pulling out the commonalities identified within all the aligned clusters researched. The infrastructural, technological, commercial, and societal conditions of hydrogen and CCUS developments mean their respective implementation will differ per region, depending on industry sector, the geographic preconditions, and policy frameworks. As part of Align, we have therefore created a toolkit for action that can be applied to industrial regions embarking on decarbonisation pathways. The toolkit was developed following interviews with researchers from each national cluster to develop synthesised learnings. The toolkit can help identify existing advantages as well as conditions and requirements necessary to successfully provide access to infrastructure and technologies. This toolkit is focused and is designed to support policy and decision makers who are in the process of delivering decarbonisation scenarios. A fact sheet has also been produced to provide a succinct overview on the requirements and methods to begin the development of CO2 clusters. This fact sheet highlights the key dimensions of industrial decarbonisation projects. Ways can be identified. It also describes whole system approaches and how key barriers can be overcome. The 4 steps of the business model developments developed in this work package are also outlined.